Good evening. So yesterday could not talk because I had some other commitments. Today I want to talk about, I have just given bird's eye view of carbohydrates and lipids. Today I'm going to talk, I will talk about amino acids and proteins. Actually, the most important molecule that has to be talked first is proteins. Protein is derived from the word protease, which says of very prime importance to our body. There are lots of definitions for proteins, and we can just say it's a polymer of amino acids joined together by peptide bonds. Very simple definition. Then we will see this in detail. And there are lots of people who want to do the classification of proteins based on its structure, based on its function, based on its properties. Based on its structure, they can be classified into very simply as globular proteins and fibrous proteins. Most of the globular proteins are functional proteins, and most of the fibrous proteins are structural proteins. When I say functional proteins, that is, they serve specific functions. What could be the specific functions? It could be a plasma membrane intrinsic or peripheral protein, which could be a receptor, which could be a channel or a transport protein, a carrier protein, or a specific enzyme, which can be a peripheral protein. Then we also have, as a functional protein on the receptor, sodium potassium ATPase. You know, it's a very, very important enzyme. It has 2 alpha chains and 2 beta chains. And also you know that sodium potassium ATPase plays a very important role in maintaining sodium potassium gradient. Same way ion channels, sodium hydrogen proton pumps. Like that, we can have so many proteins on the plasma membrane of a cell. So that is one. The next one will be, as I have already mentioned, as carrier protein. This could be transport protein in the plasma, which will carry water insoluble components in the circulation. Say like albumin is supposed to be a carrier from its role in maintaining the plasma oncotic pressure. It carries unconjugated bilirubin, it carries fatty acids, it carries some amount of calcium, it carries some drugs. So it's a carrier protein. Same way we have specific carrier protein for different vitamins and hormones. For example, if we talk about vitamin A, there is a specific carrier protein, we call it as retinol binding protein. Then there are proteins which carry steroids, steroid binding globulins. So we can give umpteen number of examples which have a carrier function. And also we can think of the functional proteins as contractile functions. So contractile proteins are, it could be in the muscle, it could be in the plasma. If it is in the muscle, the contractile proteins are, we can call it as actin myosin, tropomyosin, troponin I, T, and C. And also on the RBC membrane, we also have ankyrin spectrin also. Because I want you to remember the names of these proteins because they have physiological as well as pathological functions. They can be biomarkers also, when you are going to talk about it in the later part of lectures. Then we can say, apart from being carrier proteins muscle contraction, the most important protein of our body, oxygen carrying protein, which is present inside the RBC, we call it as hemoglobin, which is supposed to carry oxygen, and we have sometimes oxygen storing capacity protein called myoglobins. Then we have immunoglobulin molecule, which has immunological functions, complement fixation proteins, and also some of these proteins like dynein. Dynein is one of the proteins that is very responsible for motility of spermatozoa. For example, if a person is having a defect in dynein, we know that it is present in Cotton-Mather syndrome, where you have anosmia plus there is no motility of the spermatozoa. So motility of motilin, we have motilin, and then we have contractile motility ciliary proteins in the oviduct. So we can give lots of examples. So this could be called as functional proteins. Other two important classes of functional proteins are enzymes. Enzymes are organic catalysts, which could be simple proteins or it could be conjugated with certain other. So we can say that is haloenzymes. Then we have polypeptide hormones. Polypeptide hormones, classic examples are insulin, produced by beta cells of pancreas, glucagon, produced by alpha cells, and insulin is one of the most important hormones in our body. I will just come to the structure of it later. Then growth hormone, some of the growth hormone, prolactin, ACTH, adrenocorticoid hormones, FSH, LH. This could be the hormones. So we can classify them as functional proteins because they have specific functions to perform inside the body as functional proteins. So these proteins could be globular in nature, or it could have a mixed globular as well as, to some extent, part of it can be fibrous in nature also. So when we talk of structural proteins, we have structural proteins. The major connective tissue protein is supposed to be collagen. Collagen is supposed to play a very important role as a connective tissue, as a fibrous protein. And it is made up of 3 polypeptide chains. We will discuss this in detail, but for the time being, you can just see that it is a very long molecule with 1,000 amino acids in each polypeptide chain. 3 polypeptide chains together by hydroxylation reactions. That collagen plays a very important role as a structural molecule. Then we have elastin. Elastin is supposed to be very important to impart elasticity to say large blood vessels like aorta. For example, where there is heavy hemodynamic process, heavy pressure, where the blood flows onto the walls of the aorta, its elasticity is able to keep the artery functional with very, very, very minimal. Aortic aneurysm. Aortic aneurysm means a thinning of the wall of the arch of aorta. It could be in the arch of aorta or ascending a descending part of aorta. And when this thinning of the aorta is due to the dysfunctional or a defect in the structure of elastin. Elastin has unique structure. It is made up of desmosine. That is, desmosine is supposed to have 4 lysine residues condensed together. The desmosin is responsible for the elasticity of the blood vessel. And you know there are 2 common causes for this aortic aneurysm. One is supposed to be the sexually transmitted disease, syphilis. The other one is metallothionein deficiency, where there is copper deficiency that can also cause the lysyl oxidase. Lysyl oxidase is supposed to play a role in condensation of this lysine residues to form desmosin. So that can cause aortic aneurysm. And another important protein which is supposed to be fibrous in nature, which is very unique, fibrinogen, the plasma clotting protein, but it has this functional property of the globular, that is it's soluble. See, these structural proteins are not soluble in water. Fibrinogen is one exception, but it is soluble in water. And all of you know this fibrinogen is made up of alpha, beta, gamma, alpha A, alpha, beta, 6 polypeptide chains, twice the times. This alpha A, alpha B, that is A and B, are called as fibrinopeptides, which are very rich in negatively charged amino acids, which you will come across when we are talking about classification of amino acids. That is, they contain acidic amino acids. Naturally, when you have an extra acidic group, carboxyl group, it imparts negativity to the molecule at its isoelectric point, that is above the isoelectric point. And also it has a unique amino acid which is not present in any other protein, that is called as tyrosine O-sulfate. That is, the tyrosine is an aromatic amino acid with a hydroxyl group which is sulfated. That is very, very specific to fibrinopeptides, particularly B. So a clotting mechanism, in a very simpler terms, we can say removal of this negative charges. That is, removal of this fibrinopeptides A and B by the action of thrombin. So that is one important point. Then there is another protein which is very, very important for binding calcium, particularly in bone mineralization. We call that as osteocalcin. Or it also is very important for calcium absorption, that is in the small intestine. And these protein, and also prothrombin, the blood clotting protein, they are supposed to bind calcium. These proteins are very rich in one particular modified amino acid. We call it as gamma carboxyglutamic acid. These proteins are very rich in that gamma carboxyglutamic acid. So these GLA proteins are very, very important with respect to calcium metabolism, also bone metabolism. So you can see the structure of a protein is so important for its function. And I have left out one unique molecule, hemoglobin. See, when talking about the classification itself, I have talked about this classification itself. I am talking about these things to you. Why is that? Why? Because you have to keep this in your mind. See, you are all going to be doctors also. You are already doctors. You must have the capacity to understand what is the importance of these proteins, because you have to make and into your memory whenever you are dealing with a particular situation or a case. So I'm so happy to talk about this to you. So naturally, the other type of classification, we call it a simple protein, conjugated protein, and derived proteins, like what you see in lipids. See, simple protein is what? It only has the protein part. Up we can say human albumin, ribonuclease, a simple protein. So we can't think of anything else. So this is very, very important. So you have to understand this simple proteins. Then we can have complex proteins. That is, the protein part, we call it as apoprotein. This apoprotein can be complex with other non-carbohydrates, small molecules like carbohydrates. Then if it is complex with carbohydrates, we call it as glycoproteins. If it is complex with lipids, they are called as lipoproteins. If it is complex with nucleic acids, we call it as nucleoproteins. If it is complex with chromo group, chromoproteins like heme plus globin, hemoglobin, or it could be myoglobin. So we can call this as conjugated. Some good examples of conjugated proteins. Derived proteins means, for example, gelatin, and some of those proteins which are derived, they are peptones, but because of their solubilities, you can say these are all the derived proteins. The gelatin is very, very important. Why? Because sometimes you must remember, when you want, I have seen somebody collecting bones in all the slaughterhouses. Then he is called as a bone collector. Then I was wondering, what is this person doing with the bone collection? When I saw him packing a lorry load of bones, and he is sending to a capsule making manufacturing factory run with Japanese machinery, which make capsules. So what they do is, the bone is the source for collagen. From that collagen, they heat it and they get the gelatin. Gelatin becomes the structural component of the capsules. So that is very useful for making capsules. So like that we can say, when you talk about this cosmetic industry, the Roman Catholics are dead against that, simply because some of the cosmetic products produced, synthesized, according to them, they use fetal collagen. That is, they buy dead fetuses. From this, they extract the fetal collagen, and that forms the base for all those cosmetics they are using on their face. So it can be of multiple uses. So that is why proteins play a very important role. So I forgot some like that, all those things. So this could be a broad classification of proteins. I told you first as functional and structural and gave some examples. Then I told you about simple classification like simple proteins, conjugated proteins, and derived proteins. This is one way of classification. Because whenever you want to study anything naturally, you have to classify and put them under one particular category so that you understand what are its basic properties and what are its basic structure to suit its function. That's the reason why this classification of molecules, biomolecules, take place. And it is not, that is with that purpose only. It has been done. Please remember, the names of all these proteins have some significance. For example, why it is called like that, like medical terminology. So this medical terminology also plays a very important role, so that if you could remember your medical terminology well, you can also understand its function. Now these proteins, after classifying them, when you go for laboratory, they will talk about its functions, like what they do. And one of the functions they will talk about is plasma proteins. And plasma proteins also, when you take the plasma proteins that circulates in the blood, we have what is known as, what are the plasma proteins? We have albumin, globulins. Albumin is a simple protein. Globulins are classified into alpha, beta, and gamma. Alpha, beta, gamma globulins, alpha, beta globulins and albumin are synthesized in the liver. And you know that the half-life of albumin is about I think 28 or 30 days. I'm not very sure about it. I will check and tell you. And also it has a molecular weight of 65,000, and it seems to play a very important role in our body. As I have already told you, it also plays a very important role in transport of certain things like calcium, bilirubin. Apart from that, it plays a very important role in maintaining the plasma oncotic pressure of our body. So if somebody loses albumin drastically, say like in a condition like nephrotic syndrome, where there is loss of integrity of basement membrane and the integrin protein, the leakage of albumin, with heavy loss, what happens? You have edema. So naturally the loss of albumin causes the facial edema because the plasma oncotic pressure is altered. So that albumin. Globulins, alpha globulin, so many things are there. One of them could be HDL. Alpha protein is attached to HDL. And then beta globulins, we have so many examples. LDL is there. So for the time being, we can think of that. The gamma globulins, which are otherwise called as antibodies, is the only action that is synthesized in the reticular system, particularly the plasma beta lymphocytes and plasma cells. And after some time, they will try to talk about this plasma immunoglobulin molecules separately, but just for you to give a very simple explanation, the immunoglobulin molecules are having their own structure. So we'll talk about this when I'm talking about the structure also. For example, we'll talk about the structure of insulin, we'll talk about the structure of collagen, we'll talk about the structure of immunoglobulin molecule in detail. Why? Because it plays a very important role. And also here, we need to, before we embark of a deeper discussion about the plasma proteins, we will like to, let's go to the classification of amino acids before we talk about anything else. Please remember, it's very simple to remember, okay? There's nothing very complex about this. Previously, they said there are 20 amino acids. Now they are saying 21 amino acids. Then somebody saying it is 22 amino acids. That means they have extra selenocysteine and pyrrolysine. Okay, these are other 2 extra amino acids which are supposed to be. Then you also must know about taurine. Okay, so when we say amino acid, it contains both amino group and a carboxyl group. So it is attached to a alpha carbon. So when a carbon atom is there, it has 4 valencies. So we can say C is attached to H, one is attached to NH2, the other one is attached to C over here. So this alpha carbon is common for most of the amino acids. Then we have a side chain, we call it as R. So these different amino acids have different side chains. If you remember this, it is very, very easy. What could be the simplest side chain you can have? You have CH, NH2, then you have COH. What will be the simplest side chain you can have? Hydrogen atom. So if you have a hydrogen atom attached to as the side chain, that is called as glycine. The most simplest amino acid that is present in our body, but it has a very, very important vital physiological function in our body. Glycine is a very, very important amino acid. And you can see that it is attached to 2 hydrogen atoms, so naturally it is not aptically active. So this is one of the amino acids which is aptically inactive. All the amino acids are L isomers. That is the L optical isomers. So now if you remove the hydrogen atom, if you put a CH3, what happens? Instead of hydrogen atom, if you put the side chain of CH3, then it becomes alanine. Then you go on increasing the side chains, CH3, CH3, CH. What it will be? Valine. Again, add one more extra CH2, it becomes leucine. Then you make one more branching of that leucine, you become isoleucine. So the side chain, if it is branched, which cannot be soluble in water, we call it as hydrophobic branch chain amino acids. Our body is not capable of synthesizing complex hydrophobic molecule. So I told you while I was talking about essential fatty acids, anything that cannot be synthesized by the body, that needs to be supplied in the diet, we call it as essential. So branch chain amino acids are supposed to be essential amino acids. What are they? Valine, leucine, isoleucine. Glycine can be synthesized in the body, so that is why it is non-essential. Now, after this, why can't you have a side chain which is also hydrophobic? Put a benzene molecule attached to the side chain. When you put a benzene, instead of CH2 or CH3, knock out one hydrogen atom, put a phenyl there, phenyl group, that is a benzene ring. So what happens? Alanine minus H, instead of the H you have a phenyl group, so we call it as phenylalanine. Okay. So branch chain amino acids, then followed by phenylalanine. Phenylalanine also cannot be synthesized, so it has to be supplied in the diet. It is called as essential fatty acid. Here itself, I want you to remember, phenylalanine in the para position, you put a hydroxyl group, it becomes tyrosine. So you are putting only a hydroxyl group. So introduction of a hydroxyl group in a molecule is easier. So phenylalanine is the essential amino acid, but tyrosine is not essential because it can be synthesized from phenylalanine. Same way, if you put a indole ring to the side chain, it becomes tryptophan. Okay. So we can call this as aromatic amino acids. So if somebody is asking you what are the aromatic amino acids, you know two aromatic amino acids, phenylalanine, the other one is tyrosine. The third part I told you is put an indole ring, that becomes tryptophan. That is also a aromatic amino acid. Then sometimes you put a imidazole ring. Don't worry about the names of. That's why I told you when I was talking about the introduction. Take a piece of paper, write what are the possible ring structure you will come across in biochemistry. I told you put the ring structure of pyran, furan. I told you about benzene. I told you about some of these histidines, imidazole group, indole group. Like that, if you could have all these ring structures drawn, then you will never forget these things. It's very, very simple. So what all you have now seen? You have seen phenylalanine, you have seen tryptophan. Okay. Then I told you imidazole ring, it becomes histidine. So histidine we will discuss later under this section, basic amino acid, because it has imidazole group. In the ring structure, it has two nitrogen atoms. So that means that is being pushed towards the basic amino acid. Now, if you put a CH2 or a OH group, a hydroxy group added to the amino acids as a side chain, you have hydroxy amino acids. One of them is called as serine, that is CH2OH, CHNH2, COOH is serine, is it not? Then you add one complex CH3CH, then it becomes threonine. So serine is a non-essential amino acid, threonine is an essential amino acid. Why? Because you are adding a complex side chain. So what are the two hydroxy amino acids? One is serine, the other one is threonine. Already have seen an aromatic hydroxy amino acid, that is tyrosine. So in the OH group, if you put SH group can be called as sulfhydryl group. Sometimes people just say sulfur containing amino acid. So put a CSH, then it becomes cysteine. Then you put a CH3, CH2, then put an S, then it becomes methionine. So cysteine is not essential. Methionine is an essential sulfur containing amino acid. Sometimes what they do, they allow two molecules of cysteine to come together by eliminating a molecule of water, two hydrogen atoms. You have the attachment of disulfide bond. We call it as cysteine, CYSTINE. That is two molecules of cysteine coming together. What is cysteine spelling? CYSTEINE. So you have seen hydroxy amino acid, you have seen sulfur containing amino acids. So what are the amino acids we have already seen? Glycine, alanine, phenylalanine, tryptophan, histidine we have already seen. Then what we have seen now? Hydroxy amino acids, serine, threonine, cysteine, methionine and cysteine. Another. Okay. This is all of them, they have one carboxyl group and one amino group. So we can call this as monocarboxylic amino acids. They are not having extra. So that is why they are come and we can call them as monocarboxylic amino acids. Now, if you take this, we put an extra carboxyl group. We call that as aspartic acid. Introduce in the aspartic acid another CH2 in the molecule, then add to the top a carboxyl group that becomes glutamic acid. So what are they? Two carboxyl groups are present here. They are called as dicarboxylic monoamino acid. What are the names of these amino acids? They are called as aspartic acid and glutamic acid. What's the difference between aspartic acid and glutamic acid? Glutamic acid has an extra CH2 group. So alpha carbon is attached to a beta CH2. Then to the beta you are adding a COH group. Okay. Now to this carboxyl group only we have the derived amino acids already we have seen. Add another extra carboxyl group, then it becomes gamma carboxyl glutamic acid. That's number one. Then sometimes what they do, they put a NH2 group, COOH plus NH2. What will happen? CO, NH2, that is called aspartic acid in asparagine. You know, asparaginase, it comes under pharmacology. Same way, glutamic acid plus amino group, it becomes glutamine. You know, glutamine, they will always ask you what is the carrier of ammonia group in your bloodstream. That always you must think about glutamine. Glutamine plays so many important roles in the structure of urine, pyrimidine, as well as in other places also. But also it is one of the important carrier of ammonia from the brain cells to the liver. Okay, that is glutamine. So you are now, what is that? Glutamic acid, aspartic acid and glutamic acid, gamma carboxyl glutamic acid, asparagine and glutamine. So they can be called as acidic amino acid. They are all having dicarboxylic monoamino acids. The other one, now we will have an extra basic group. What are the basic amino acid? The most important basic amino acid is lysine, L-Y-S-I-N-E. CHNH2, COH. Then you put CH2, 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 4 group. The epsilon group, you have another amino group. So the epsilon amino group is called, it imparts lysine. So that is, what is lysine? CHNH2, COH. Above that, CH2, 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 CH2. On top of it, you add a NH2 group, that is the epsilon carbon, you become a lysine. And lysine is an essential amino acid. Glutamic acid, aspartic acid, they are all non-essential. That's why I didn't talk about essential amino acids. Then you have another important compound, arginine. Sometimes some people have called arginine also a wonder molecule. Then this arginine also is a basic amino acid because it has a gonadium group. What is the basic group present in arginine? It has gonadium group. So this is a gonado amino acid. It is otherwise called as arginine. Same way you have what is called as the basic, another amino acid which I have already seen is histidine. Okay, this is the amino acids that are present in our body. Please remember, these amino acids are very simple to remember. What are they? You have to have the major alpha carbon atoms attached to NH2 COH. The side chain only differs. What you do is write the basic structure of amino acid, then write separately the side chain, then attach them, then you get all the amino acids which are present. There were 3 stop codons in our body, UGA, UAG, and UGA, UAG, and UG. Is it? So these stop codons, one of them is now converted to form which converts serine into cysteine, and that becomes selenocysteine. The 21st amino acid now is considered to be selenocysteine. Please remember, selenocysteine is very, very important for our system. Particularly, it is supposed to protect our RBC membrane against peroxidative damage so that it does not lead to severe hemolysis. It is present in some important enzymes of our body. One of the enzymes you will see is superoxide, like that glutathione peroxidase. Glutathione peroxidase, please remember here, contains selenocysteine. The other one is pyrrolysine. Pyrrolysine, we'll think about this. So that's supposed to be the 22nd amino acids. One of the questions that they ask in PG entrance examination is one like, which is the most important essential amino acids for a newborn baby? Cysteine. methionine, cysteine, taurine. So all of you will go and answer the question methionine. It is not methionine, it is taurine when you are talking about newborn baby. So it is very, very important. Same way, another important amino acid which we will come across, which is not alpha amino acid, it is a beta amino acid. We call it as beta alanine. Beta alanine is very, very important for our system. You can see beta alanine is pantothenic acid, coenzyme A. In so many other places, beta alanine will be there. Carnosine. Carnosine is present in the muscle. So that plays a very important role there. So beta alanine is very important. And they usually ask these questions, I think, in the NEET or the PG entrance examination. So you can remember that beta alanine is also a very important amino acid that is present in our body. So today's class, what I have done is I just gave you this explanation of proteins, classification, amino acid and its classification. There are other methods of classifying amino acids also, hydrophobic, hydrophilic. Then we can say, what are the other, one more thing is based upon all the amino acids. But the most important thing is glucogenic, ketogenic. Both glucogenic and ketogenic classification is also there. So please remember to have those classification also. Only simple thing, one thing always remember, purely ketogenic means it has to be lucid. All the other things, some of them could be glucogenic because when it is broken down, they can give rise to a keto group also and also the glucose intermediate. That is why they are called as both glucogenic and ketogenic. So this is another way of classifying these amino acids. Keep this in your mind. Please, the most important thing is, I like to talk about one important aspect, just give an introduction, continuing this in my next lecture. That is about hemoglobin or myoglobin. One of the most wonderful molecule of this planet, or the miraculous beauty of God's gift to human being, is hemoglobin. They are trying so hard to replace it with any oxygen binding protein. They have been doing lots of research on this, particularly during emergency to give blood transfusion. They were trying so hard to replace a molecule called hemoglobin, which still does not satisfy the marvelous role played by hemoglobin. I do not want to delve deep into this, accepting that it's the most wonderful molecule everyone must appreciate. That is why we have classified some of the amino acids as hydrophobic and hydrophilic. Hemoglobin molecule is called as a molecular lung because when it gives out oxygen, it becomes a taut molecule. When it takes up oxygen, it becomes a relaxed molecule. So this switching between relaxation and tense structure or taut structure has given the name molecular lung to hemoglobin molecule. And it is supposed to carry oxygen, and that bond between the hemoglobin molecule and the oxygen cannot be a permanent one. It has to be a loose bound molecule, that is like picking up oxygen and delivering it. Pick up and delivery. That is the function of hemoglobin. For that, what they have chosen. They have seen so many other ring structures. They finally come to what is a ring? Porphyrin ring. Porphyrin ring, it is supposed to have 4 pyrrole ring joined together by methylene bridges. We call it a porphyrin ring. In this porphyrin ring, they put an iron atom into this, that becomes heme. Tetrapyrrole ring with heme atom, iron atom attached to that, it becomes heme molecule. See the beauty of it, how it is done. So what it can do, it can form coordinate linkages. You know about covalent bond. We'll come across. I will try to discuss this covalent bond, hydrogen bond, salt bridges, and now the covalent bond. That is, the heme molecule can coordinate. The 4 nitrogen atoms that are present are attached to the iron atom. Now, if you leave this heme molecule floating into water, the iron atom has the capacity to fluctuate between its oxidate state and the reduced state. The oxidative state is ferric ion and the reduced state is ferrous ion. By donating an electron, it becomes ferric. By accepting an electron, it becomes ferrous. So if you expose it to water, what will happen? It is permanently oxidized to ferric and it cannot bind oxygen. So the 6th linkage is for oxygen. So naturally, this has to be protected from a water or aqueous environment. So that is why it is kept inside the hemoglobin molecule in a waxy packet, a hydrophobic packet. What is that hydrophobic packet? How can you create a hydrophobic packet? By having hydrophobic amino acids lining inside the molecule. So it has a waxy packet in which it is kept, the heme is kept, so that the iron atom is kept in the ferrous state. That is the reason why the protein structure is very, very important for hemoglobin function. I will stop with this by telling one important point which you must remember in your mind. Today, you and me are alive simply because of the structure of hemoglobin is being maintained. How it is maintained? For this hemoglobin iron atom, carbon monoxide has 250,000 times affinity than oxygen. So what will happen is, it's the simple carbon monoxide that is being released from the exhaust pipes of your car or the air conditioner can form a carboxyhemoglobin, and you know what cyanosis, and you can die, is it not? To make us live. The carbon monoxide wants to make a vertical bond with the iron atom. So what happened in hemoglobin? It put a histidine molecule in front of the porphyrin ring so that the bond is not vertical, it is tilted 45 degrees centigrade. This tilting of the bond from vertical to 45 degree has reduced the affinity of carbon monoxide from 250,000 times to 250 times. And if you remove this histidine, what will happen? You will not die, you will die. Like incompatible life you will have. So this histidine, just one distal histidine. We will talk about so many other things like proximal histidine. We will talk about the structure in our next class. That is the reason why please understand your biochemistry. And if you understand your biochemistry, it is the most wonderful thing about understanding your life. And hemoglobin is one such molecule that can just bewilder you, dazzle you, mesmerize you, how it functions in our body, what nature can do to us. Can we conquer nature, or we call the superpower? Please think about it. And always have an inquiring mind. Keep your mind open. There is a saying, parachute can function only if it is kept, if it is open. Same way, when you keep your open mind, when you have an open mind, so many new things can strike your mind. Who knows? Some of you can think about a concept, and biochemical concepts are ever changing. It's not static, it's dynamic. That is why biochemistry is a very dynamic subject which can so easily explain the greatness of God, greatness of Jesus, or greatness of Allah, greatness of Shiva, or greatness of any superpower. So keep this in your mind. All of you have a nice night. Good night. May God bless you. Thank you very much.